Hello and welcome to our video on degrees and radians. So I'll keep my radians in green. I think I'll try to do that. So these two things come up in trigonometry and they're closely related. They describe angles in different ways. And we can look at a circle to understand what's going on. So if we draw a circle, this is my circle right there, and the circle has a center. What's going on here is that in a circle we say we have 360 degrees. So if I draw a line from the center to the outer edge of the circle, and then I measure the angles in the circle, the angle in the circle, full rotation, that full rotation is 360 degrees. So 360 degrees equals a full rotation, and that's the measure of a circle. And once we say that, we can think about degrees as, well, if a circle has 360 degrees, and we want to know what 1 degree is, we break that into 360 parts, and each little part will be a degree. And that's kind of the idea of degrees. It's based on this idea in a circle that if we go around the full circle, we have 360 degrees. I'm trying to erase this here. Well, radians are also based on this idea of a circle. And the circle, it's interesting to me that the circle is just so fundamental to our understanding of angle measure. And in fact, so many things are based on the circle. And also, you'll see some of these formulas between radians and degrees. It's nice to know that if you go back, they're tied together by the circle. The radian also looks at the circle, like I said, and it just says that, okay, well, if I draw a radius here and a radius somewhere else, what will happen is I form this angle. And also what will happen is I cross this arc right here. The arc is this point of the circle. It's crossed by the two radiuses, the radius and the radius that I drew. Now, a radius just goes from the middle of the circle to the outer edge. Well, when this arc subtends this angle, let me write that word down, subtends. This comes up a lot in radians. This angle subtends this arc, and this arc subtends this angle, which basically means that the arc crosses the path. It's hard to say. The arc crosses the path of the two radiuses, and it matches in a way where the angle is. We can look at other examples of subtending and one is not subtending, but more or less right now, this arc subtends this angle because they match, right? This part of the circle is matching where this part of the angle is. This arc over here, for example, is not subtended by this angle because it's over here. So the idea is the arc has to be between the two rays of the angle. Okay, anyway, I was going off topic there. So we know that a circle has 360 degrees, and we know that this arc is subtended by this angle. The cool thing about the radians is what we're really measuring is how many arc measures of one radius do we have. So what we're saying is this arc right here is equal to one radius. So when we're talking about radians, we have arcs that equal the length of one radius of the circle we're using. So for example, let's quick sketch down here. If we had these two lines and we said, well, what's this angle? You can measure it in degrees. Or you can say, well, okay, well, how many radiuses from here to here, if I had like a bigger circle, that's terrible, oof, sorry. How many radiuses is that length from this point to that point? That's the question. How many radiuses are there? And that's what we're looking at in radians. Now, there's an easy connection between these two if we go back to the full rotation of the circle. A full rotation of a circle, if I go all the way around a circle, what I'm looking at is the circumference. So one full rotation, so a full rotation, that's called a circumference. And I'll just write as CIRC, circumference. And circumference, C, is equal to 2 pi r, or 2 radiuses times pi, because the circle is about pi times longer around than it is across, and 2 radiuses is how long the circle is across, so it's about 3 times longer around. Anyway, if that's true, if the circumference equals 2 pi r, and 360 degrees equals a full rotation, now we have this connection. I'm going to write this connection, I think, on a new page. So for radians, if if we go around a circle, what we have is 2 pi r equals the full rotation. And for degrees, that equals 360 degrees. So they're saying the same thing, and the circumference around a circle is 2 pi r, which means the circumference around a circle can be thought of as 2 pi radians. Because here what we're saying is we have 2 pi radiuses, and we're looking at every radius is 1 radian, so 1 radius equals 1 radian. So I'm just going to substitute that idea into this equation. So we have 2 pi radians instead of 2 pi radiuses. So how long is a circle around? Well, it's 360 degrees, or it's about 6 radians, right? 2 times about 3 is a little more than 6 radians, and they're equal. And now we can define these things in terms of each other. So 1 degree, if 360 degrees equals 2 pi r, well then 1 degree, we divide by 360, 2 pi over 360 r. This is equal to 1 over 180 pi, so it's pi over 180 r. That is what 1 degree is equal to. So I'm going to write that down. 1 degree equals pi over 180 radians. And now I don't actually memorize this formula. I derive it. So that means I always go back to this formula right here. I think about the distance around a circle. And I take that and I create this. Or you can go the other way and figure out what happens if I have 1 radian. How many degrees is that? Well, if 2 pi radians is equal to 360 degrees, and I want to know what 1 radian is, I could divide by 2 pi on both sides. This cancels out, right? Anything divided by itself is 1. And over here we have 360 divided by 2 pi. That's 180 over pi, which means that 1 radian equals 180 over pi degrees. Remember, I wasn't writing the units in. Maybe I should have. But this was degrees, and this is radians over here. So 1 radian equals 180 over pi degrees. And these two formulas allow us to take anything in degrees or radians and convert it to the other measurement. So let's say I start with, we could pick anything here. If we start with a certain degree measure, what if we start with 45, right? Pretty standard degree measure for 45 degrees. What is that going to be as radians? Well, we can use our formula up here. 1 degree is pi over 180, so 45 degrees is 45 times that. So 45 times pi over 180 radians. And we're going to simplify that. So we get 45 over 180. I'm feeling tired right now, so I'm going to recognize that they both have a common factor of 5 and divide them by 5, and then most certainly I think I'm going to divide again. But 45 divided by 5 is 9. 180 divided by 5, well, 100 divided by 5 is 20. And 80 divided by 5, well, 5 times 10 is 50, so it's 16, so that's 36. And again, I'd write 9 and 36 both have 9 in common. Before I even write anything further, I'm going to divide these by 9. I get 1 over 4. And the answer here is 1/4 pi radians. And you could write this. You can say, well, 45 degrees is equal to 1/4, right? 1/4 pi radians. And that makes sense if you think about it. If you have a circle here, 45 degrees is this right here. And if this is the radius, well, 1/4 of times 3 is about 3/4 of a radius. And that even looks about right, that this is about 3/4 of a radius. Here's the radius right here, almost a full radius. And so that's how these degrees match that radians. And we can do other examples. What if I had 90 degrees? What's that? Well, I've already forgotten my formula because I've changed pages. But I remember that 360 degrees are in a circle. And that equals 2 pi r, so 2 pi radians. So 1 degree, deriving it again, equals, I'm dividing by 360 on both sides, so I get pi over 180 r. So 90 degrees is equal to 90 times pi over 180 radians. 90 over 180 is just 1/2, so it's 1/2 pi radians. And that's equal to 90 degrees. And we can go the other way. We can start with radian measures and find degrees. So what if I had pi over 2 radians, and I want to know, well, what is that in degree measure? Go back to our formula. We have this right here, except now we want to know what radians are. So we divide both sides by 2 pi, and we get 180 over pi degrees, and that equals 1 radian. So we have pi over 2 radians. Here we have 180 over pi radians. 180 over pi degrees equals 1 radian. So we're going to multiply both sides by pi over 2, because here 1 radian is this, so pi over 2 radians is pi over 2 times 180 over pi degrees. The pi's cancel out. 180 over 2 is 90, and pi over 2 radians equals 90 degrees, which is actually what we had right here. Pi over 2 radians is equal to 1/2 pi radians. Same thing. Dividing by 2 or multiplying by 1/2, those are equal. And I think there's maybe an even easier way to think about this. If 360 degrees, probably could have just used this original formula here, equals 2 pi radians. Well, 2 pi radians is 360. Here we have 1/2 of a radian. 1/2 of a radian is 4 times smaller than 2 pi. So this will also be divided by 4, and we get 90 degrees. But either way, we always go back to our original formula that if a circle has 360 degrees, and the circumference of a circle is 2 pi r, and 1 radius is 1 radian, so we can think of the circle as being 2 pi radians around. And we then can connect the degrees and the radians through this formula. It's pretty cool stuff.